Electronic Basics, Video 4, Resistors. Resistors are the backbone of electronic circuits. It limits current flow, prevent damage in expensive components, and in many cases work as a potential divider. In this video, I'm going to teach you how to read a blue resistor and a beige resistor. Resistors come in a string like this. Usually, there is any printed saying how much this resistor or is in the packaging. But sometimes we need to figure out what is the value of this resistor. The unit for a resistor is ohm, and the abbreviation is omega. When we need a resistor, what we need to do is just detach from this, and now we have the resistor with the terminals, and it's very flexible. And the same thing with this one that is beige. Okay, so we have the terminals, and I'm gonna teach you how to read using the barcode. All resistors, beige or blue, have vertical colored lines. To read the value of a resistor using the color code, I'm going to use this textbook from IGSI Physics, page 178 right here, and just the numbers, just these numbers right here. That's what I'm gonna use to read the value of the resistor. The difference between a beige resistor and a blue resistor is the number of bands. For example, the beige resistor, we have here 4 bands. And the blue resistor, 1, 2, 3, 4, 5 bands. Let me start with the beige resistor. So the first band is the first number, the first digit. The second band, the second number. The third band is the number of zeros. And the fourth band is the tolerance. Now first I need to identify the colors of the bands of this particular resistor. So the first thing I do, I place the resistor facing to me in a horizontal position, and with the shiny band on my right. The shiny band for a beige resistor indicates the tolerance. So then I identify the first color, in this case is red. The second color is red, and the third color is black. And the fourth color is gold. According to this table, each color is associated with a number. So red here is 2, and black is 0. And the gold is plus minus 5%. So the rule is this. The first color corresponds to the first number, which is 2. The second color corresponds to the second number, which is also 2. The third color corresponds to the number of zeros. So black, the number corresponds to black is 0. So which means there is no zeros in this number. And gold corresponds to the tolerance. So in this case is plus minus 5%, which means that this resistor can fluctuate from 22 ohms plus minus 5%. So this resistor is 22 ohms plus minus 5%. To read the blue resistor, we have to follow the same procedure that we did for the beige resistor. So we need to place the resistor in front of you and identify the tolerance. Usually the tolerance band is a little bit away from the other bands. So I can see this one here is a little bit away. So that's why I'm facing the resistor this way. Otherwise, if I do this way, so I will be reading first the tolerance, and this is not correct. So this is the correct way to read. Tolerance is the last one. So in this case, I'm just going to identify the color bands for the 4 lines. So this one here, I can say that is red. The second one is black. The third one is black. And the fourth one is also black. And the fifth one is the tolerance. In this case, I'm just going to read the 4 first bands. So red is 2, black is 0, black is 0. Now, the fourth one is the multiplier or the number of zeros. So since it's black, there is nothing's there. Now, the tolerance, the difference between the tolerance between the beige and the beige and the blue resistor is that the blue resistor can have here any color, not only gold and silver like the beige one. And usually the tolerance is smaller than the tolerance for the beige one, because this is usually used for electronics and you want more precise values for resistors. So in this case, the value of this resistor is 200 ohms. To read any resistor, place the resistor horizontally facing to you with the tolerance on your right. So you need to identify the tolerance. So in the beige one, it's very easy to identify because usually comes in 2 colors. One is gold, one or silver. So it's easy to identify. So, and then you just follow the sequence. Here it will be, you read red, black, and then gold. So the first number is the first digit. The second number is the second digit. The third number is the number of zeros. And the last one is the tolerance. So in this case, we use the color with the corresponding number. And in this case was red 2, black is 0, and gold tolerance is plus minus 5%. So then this beige resistor is 22 ohms plus minus 5%. For the blue one, we have the same approach. Place the resistor horizontally in front of you with the tolerance to the right. To identify the tolerance, you just need to look how the bars, the bands are close to each other. Usually the tolerance for the blue one is a little bit more far away. So once you identify that, you can just find the colors for each band. So the first one here is red, the second one is black, the third one is black, the fourth one is black, and the last one is orange. So the blue resistor doesn't use gold or silver for tolerance, can use colors from usually the upper level here because we have less tolerance on on the blue resistor than compare with the beige one. So the red one is 2, the black is 0, black is 0. Now the fourth band corresponds to the number of zeros. Here is indicated as multiplier, which is the same thing. And the last band is a tolerance. In this case, is orange, so is plus minus 3%. So to read the value of this resistor is 200 ohms plus minus 3%. Let me use this multimeter to verify if the reading is correct. So in this case, you need to go to this side of this multimeter. Because I read 22, so there will be my minimum value, which is 200 ohms. And then I'm going to, because resistors are not polarized, so not matter if I connect the positive terminal of the multimeter on each side, will read the same value. So this is 21.8, which is correct because you see here the tolerance. So the tolerance indicates that this value can be a little bit over 22 or below 22. So perfect. Now let me check the value of this blue resistor. So it says 200. So I should be fine with my dial on 200. Let's see what happens. If you be over 200, this setting will not read, will show OL. And then the solution is to move up. But let me start with 200 because according to my reading, this is 200. So let's see what happens. Okay, it's not reading. Oh, because it's okay. So was in amps. So you see is 198.9 because the tolerance again. So the reading is perfect. Good job.